Amid the vast silence of the cosmos, where light travels for billions of years and mysteries unfold beyond imagination, humanity has crafted a new eye, an instrument with the power not just to see, but to reveal, to illuminate the stories that have been hidden for eons. Tonight, we find ourselves standing on the edge of a truly spectacular cosmic revelation. Thanks to the James Webb Space Telescope, the universe has shown us one of its rarest performances. Black holes, previously veiled behind thick clouds of cosmic dust, caught in the act of devouring stars. It's a drama played out millions of light years away, yet with Webb's sharp infrared gaze, we can finally witness the spectacle and feel the tremor of awe echoing across space and time. For decades, black holes have existed in the collective imagination as both monsters and mysteries, regions of space so dense and powerful that even light cannot escape. But remarkably, most of the time black holes remain invisible, blending into the background darkness, their presence only felt during brief, cataclysmic outbursts. When, through cosmic happenstance, a star dares to stray too close, the black hole's gravity ensnares it, tearing it apart in a violent episode known as a tidal disruption event. As the star is shredded, its remains circle the black hole, forming a disk of glowing gas that can shine in X-rays, ultraviolet, and visible light, a sudden blaze momentarily illuminating an otherwise silent corner of the universe. Yet while these cosmic feasts are certainly bright, most are hidden behind dust, cloaked and shielded from telescopes that rely on visible light. For years, astronomers could spot tidal disruption events only in the rare galaxies where gas and dust were sparse, the landscapes relatively free from cosmic smog. Yet across the universe, the most bustling stellar neighborhoods, the very galaxies packed with gas and dust and newborn stars, remain inscrutable. The orchestration of dust, ironically, both conceals and reveals. It blocks some kinds of light, but when energized by a star's destruction, it heats up and starts to glow itself, shining brightly in the infrared. Here, the James Webb Space Telescope is nothing short of transformative. Tuned precisely to the glittering heat of the infrared spectrum, Webb takes our vision further than any instrument before. With unprecedented sensitivity, it can see through thick smoke and unravel mysteries lost to all previous telescopes. Imagine a cosmic detective, able to look straight through veils once thought impenetrable, searching out the hidden drama taking place within the hearts of distant galaxies. A team led by astrophysicist Megan Masterson at MIT took on this cosmic challenge, poring over archived data and searching for the elusive signatures that would betray a black hole's secret feast.
What the telescope found rewrote the script of what we thought possible. Within the swirling chaos of these dusty galaxies, Webb's infrared instruments detected light that carried unmistakable fingerprints, atoms that had been stripped of their electrons by fiercely intense X-rays and ultraviolet radiation. These emissions, far from ordinary, are signals broadcast only when a black hole is in the act of tearing apart a star. Even more striking, Webb picked up evidence of silicate dust grains swirling around the black hole, precisely what you'd expect to see when the energy of a shredded star is crashing into clouds of glassy cosmic sands. The researchers cross-checked these signals against detailed computer models, confirming that the patterns matched exactly with what a hidden, dust-shrouded tidal disruption event would produce. In fact, these weren't the bright, steady emissions of black holes that are constantly feeding what astronomers call active galactic nuclei, but sudden, time-shifted flare-ups caught in the act by Webb's acute vision. One of the most astonishing aspects of these discoveries is the timing. The light from a black hole's meal, visible in X-rays or ultraviolet, might reach us first, but in the dusty regions, most of the energy is reprocessed by the surrounding dust and emerges as infrared light, only after a delay of several months. It's as if we are witnessing the aftermath of an interstellar crime scene, the initial act long over, but the echoes still rippling through space, detectable by the right set of eyes attuned to the correct spectrum. Webb, unique among telescopes, can see these delayed clues, capturing a hidden universe that has long evaded all who came before. This is far more than a technical triumph. It is a profound leap in our understanding of the cosmic life cycle. For generations, astronomers have hunted for the brightest explosions, the loudest cosmic signals, simply because those were the only ones we could detect through the dark. But now, with the ability to see through dust, the realization dawns. Many black holes may spend their lifetimes waiting in silence, only occasionally lit by the briefest of stellar encounters. Without the keen perception of the James Webb Space Telescope, these fleeting, secret moments would remain forever in the shadows, unobserved and unknown. Consider what this means for our map of the universe. All across space, with entangled birthing galaxies and quiet older giants, there may be hundreds or thousands of such events happening right now, just beyond our old reach. The cosmos is far more lively, more active, and more surprising than our former dust-blind view allowed us to dream. Technologies like Webb gift us with vision not just to see, but to understand how black holes and the galaxies they inhabit truly live and die. This milestone reminds us how questions, once thought impossibly distant, become real as tools advance and curiosity remains unyielding. Look at the very act of using the James Webb Space Telescope. The years of engineering that led to a telescope able to stare into the hidden heart of creation. It's an alliance between patience and ingenuity, a feat born from the desire to know what lies beneath the surface. And yet, the story doesn't end with black holes and their cosmic meals. In another corner of our newly revealed universe, the James Webb Space Telescope has delivered yet another surprise. The discovery of giant rogue planets, meandering between the stars, unattached to any sun. These aren't just lonely wanderers. Some are so immense, they may have the power to host their own planetary systems, becoming miniature solar systems drifting through interstellar space, free of the gravitational embrace of a star.
Just imagining this, we are asked to expand our minds beyond the familiar models. We have long assumed that planets are the children of stars, born from swirling disks in bright, sunlit systems. But Webb's observations reveal a universe that is far more anarchic, more varied, and perhaps more hospitable to the bizarre than we'd ever believed. Rogue planets, some massive enough to command moons and even ring systems, are out there, forging their own destinies in the solitary darkness between worlds. In the grand tapestry of the cosmos, no story is too strange, no possibility too unlikely. Every glimpse through Webb is an invitation to deeper mystery. Amid these astronomical wonders, we're reminded of the human journey as well. Consider for a moment NASA's Voyager 1, a small spacecraft now charting its impossible course at the very edge of our solar system. For more than 4 decades, Voyager has soared onward, breaking every record for distance and endurance. And still, questions remain. How long until it finally leaves the sun's domain behind altogether? Is the journey 30 decades or 30,000 years? Such scale defies the imagination, but like the discoveries of Webb, it marks the spirit of perseverance and wonder, a testament to the reach of our curiosity.